Hi everyone, Mr. Lee here. In this video, we're going to go over the introduction to charges. All right, let's begin. So to start us off, let's go over the types of charges that we can find in a atom. So a atom is the things that make up all of the matter in our universe. Okay, so if you were to get, let's say, a pencil, and you were to break it down over and over and over again, eventually you'll get to a point that we call the atom. Now, up until recent physics history, we thought that the atom was it, right? We didn't think that we could take that pencil and divide it even more, but now we know that if we were to take that pencil, divide it, we get to this thing called an atom, and even from there we could split the atom, but we're not going to go into there just yet. So let's go over the parts of a atom. Now, for our class, the atom consists of the electron, it consists of the proton, and it consists of the neutron. Now, the proton and the neutron is part of this thing called the nucleus, and the Bohr atom of the model is something that you might be familiar with. It is the model of the atom that a lot of media uses. So here we have the nucleus with the positive protons and the neutrons in there, and then we have these orbitals, and around those orbitals we have these things called the electrons whirling around. Now, this is just a model. It is not an accurate representation of what is actually happening. Okay, so for one, we know that inside of the nucleus we have protons, we have neutrons, and we can actually find the electron in there, believe it or not. Now, something that you do need to know, the proton that is held within the nucleus, it is held together by this thing called the strong nuclear force. This electron is whirling around the nucleus, and it's whirling around in this area called the the electron cloud. Okay, all right. Now, this is what we need to know. Let's add to this knowledge. Oftentimes, you'll see me write electron as E to the negative, okay, that negative superscript. Sometimes you could see me write proton as E with the positive. Right? It just shows us that we have a positive and a negative charge. But speaking of charges, we write charges with a letter Q for charges. Okay, we reserve C for the speed of light. Q is for charges. So you can see, that's a G. Electron sometimes be written as Q negative, and a proton as Q positive, but all of those are the same. Now, the charge of a electron would be negative 1.6 times 10 to the negative 19, capital C for coulombs. That's C-O-U-L-O-M-B-S, coulombs, named after the physicist Dr. Coulomb. I forgot his first name. Okay, so that's the charge of a electron. The charge of a proton is the same, but it'll be the positive value, 1.6 times 10 to the negative 19 coulombs, but it will be positive. All right, now another thing that you need to know is the proton mass. The mass of the proton is 1.67 times 10 to the negative 27 kilograms. The mass of the electron is 9.11 times 10 to the negative 31 kilograms. And the mass of the neutron is 1.67 times 10 to the negative 27 kilograms. Important to point out, and I'll highlight this, that the proton and the neutron, they have the same mass. The electron has a smaller mass than the proton. So we can write out this relationship like so. Okay, now let's get into the actual charges. Okay, so we have these things called positive charges and negative charges. A object can have X amount of positive charges and a X amount of negative charges. So what I'm about to introduce to you is this concept called the conservation of charges. Conservation of charges. Okay, so this states that in our universe or within a system, no charges can be created or destroyed. And you know what? Let's write that down. Within a system, no charges can be created or destroyed. Okay, and this is a very important law. this is one of our conservation laws. Much like the conservation of energy or the conservation of mass, the conservation of charges is relatively the same. So what this means is, let's say that we have a object, okay, and this object has both positive charges and negative charges. Now, I know I just drew two of them, but I'm just going to write it down here that for positive, let's say we have 10 coulombs of positive charges, and we have, let's say we'll have 10 coulombs or negative 10 coulombs of the negative charges. Okay, so what that makes is that this object is now considered to be neutral, because positive 10 plus negative 10 gives us 0. So this here is a neutral object. Now, what the conservation of charges says is that no matter what happens, is that we must always have this combination of charges so that the system overall is neutral. So let's say that we removed -5, okay, -5 coulombs of charge from this object. So here we have a overall positive object. Okay, we have an overall positive object, and I'm showing you that it's overall positive by drawing more positive charges. We'll throw in a negative charge in there. And what we can say here is that the negative charges, remember we took away -5 charges, so instead of having a total of -10 coulombs, we have a total of -5 coulombs of the negative charge. And draw a little circle around that. But we didn't touch the positive charges, so we still have 10 coulombs of the positive charges. So overall, this object is, 10 plus -5. Overall, this object is positively charged. Okay, so you might be asking, well, according to the conservation of charge, where did those -5 coulombs go? Where did those -5 charges go? Now, in the next video, we're gonna go over how to move charges, but for the sake of this little example on systems and where charges can go, we can say that those -5 charges, we moved it to another object here, okay? And we put those -5 charges on 3, 4, 5 on this object here. So if we're looking at the system overall has the same amount of charges. So this round object has positive 10 and -5, and this rectangle object has -5. So overall, the system has a total of a neutral amount of charges. Okay. So now this is really cool because if you think about it, much like the conservation of mass, or the conservation of energy, the conservation of charges, the charges that we have here on Earth, pretty much, more or less, is the same amount of charges that we started off with, the grand scheme of things, since the beginning of our universe. Okay, charges can't be destroyed; they just go from one object to another, or one form or another. Okay. Now, another thing that you need to know is for positive charges. Okay, so here is the law of attraction / repulsion. Like charges repel. Okay, and unlike charges attract. All right, so like charges repel, unlike charges attract. So what this means is that if we have objects, we're going to go into this a little bit more. We're going to do a couple of in-class demos that really show us this. But let's say we have two positive objects. So these two positive objects will repel. If we have two negative objects, these two negative objects will repel. So it's kind of like balloons, right? If you have two charged balloons and you bring it together, they will repel. Now, what about unlike? So if we have a negative charge with a positive charge, these two will attract to each other. It's kind of like if you take like your socks out of the dryer, the socks, it'll be attracted to, if you put it against your body, the sock will be attached to your body or your clothes, okay? So the two will come together. The other iteration of this is positive or a negative, but they are near what we call a neutral object. Okay, so notice here the positive and neutral and negative and neutral, they're both not the same charges, therefore they will also attract. And we'll go into all of that in the next video as well. All right, the last thing I want to cover are different types of objects that we will go over. The first one we call conductors, and the second one we call insulators. Okay, now under conductors we can say most metallic or metal objects are conductors, and under insulators, just as an overall, I guess, category, we can think of like plastics. Okay, we can think of like cloth or cotton or wool or silk, even glass. Okay, most other objects are considered to be insulators. Metals are considered to be conductors. Now, there is a table that goes over what are good conductors and what are good insulators, but that is for another time. So the big difference between the two is that we can say that conductors is that the negative charges move freely. Okay, and for insulators, the negative charges are held in relatively the same space. Okay. So as a quick little demo, or a quick little illustration or a little model, if we have a metallic conductor, okay, we have a metal bar, and here we have a plastic rod. So what this means is that if we were to have negative charges around, okay, so both objects have negative charges around. Now this is in a neutral state, right? So I'm just highlighting the negative charges, but just so you know, there are positive charges there. You know what? I will also draw the positive charges, so should you, just to show that we have here a neutral object. All right. Now for a conductor, I'm going to do this in a different colored ink. Let's do black. All right. So for a conductor, what it means that the negative charges are free to move around is that for whatever reason, okay, we force the negative charges to move from one place to another. So we can force these negative charges to move all the way to the left. Okay, so we can have all of those negative charges move over here. So I'm going to erase the negative charges. Okay, so we can move the negative charges around. Now notice here that the positive charges do not move. Positive charges do not move. It is very important for that. And the reason for that is, if you remember from the very beginning, positive charges make up the nucleus, and the nucleus is what makes up the object itself. Okay, and so we can't say that the nucleus of the atom is actually shifting. Right? So we say that the positive charges do not move, only the negative charges. Now for an insulator, what happens is, and I'll also draw this in black, if we want to force all the negative charges to the right, what happens is that the negative charges just slightly move to the right. Okay, they just slightly move to the right, leaving us with, I will clean that up in a little bit. There we go. So positive here, we got a positive here, positive here, positive here, positive here, positive here, positive here, positive here. So notice how all my negative charges are just to the right of the positive charges, or my negative charges are slightly to the right of the positive charges. Okay. The big difference is that between the conductor and the insulator, for the conductor, all the negative charges move all the way to the right. For the insulator, they just slightly adjusted to the right. Okay, and that's a big difference for the conductors versus the insulators. And when we go over the methods of charging, this will come back. All right, that's all for today. I'll see you next time. Bye-bye.